Time now to look at the remainder and factor theorem. You may have seen these before. The remainder theorem says that when p of x, a polynomial, is divided by x minus a, the remainder is p of a. So in other words, if you had x minus 3, you were dividing into a polynomial, what you would do is put 3 into the polynomial where x is, okay, and whatever the result is, whatever p of 3 is, okay, would be your remainder. So that's what that theorem is saying. If you're dividing in an expression such as x minus 3, x plus 4, x minus 2, x plus 7, you put the opposite sign into the polynomial, you'll get the remainder. So what if the remainder was 0? Okay, if the remainder is 0, it's a factor. For example, if you divide 3 into 12, you get 4 with no remainder. So 3 is a factor of 12 because it divides in evenly, no remainder. So the factor theorem says that if we divide in and we don't get a remainder, we're looking at a factor in that situation. So they're the two theorems we're going to look at here, and we're going to concentrate now on the factor theorem. By the way, if there's a coefficient in front of x in your expression that you're looking at, you put the opposite sign in. So if it's b, you put negative b in. If it's negative b, you put b in over that coefficient. Okay, and if you put that in and get 0, then ax plus b is a factor. So putting that a concrete example to that, if you're looking whether 3x plus 1 was a factor of p of x, it would be a factor if p of negative 1, so you've got positive 1, you make it negative, over the coefficient of x. So if p of negative 1 on 3 was 0, then 3x plus 1 is a factor. If you were dividing in 4x minus 7, then you would be looking at whether if p of 7 on 4, if that was 0, then 4x minus 7 would be a factor. So it's opposite sign or opposite sign over coefficient of x is what you're putting in. Right, so if you want to determine whether or not x minus 3 is a factor of that polynomial, what we're looking at is p of 3, opposite sign. Notice we've got negative 3, so we're putting in 3, is p of 3, does it equal 0? Okay, so let's have a look. So p of 3, we place 3 into the polynomial. Practiced this skill the other day. So it'll be 2 times 3 cubed minus 4 times 3 squared minus 3 times 3 minus 8. So that's 54, because 3 cubed is 27 times 2 is 54, minus 36, 4 nines are 36, minus 9 minus 8. And sure enough, if I add those up, they're not going to equal 0. That put me off there for a moment. Okay, remember the question's asking whether it is a factor or not. If I actually look at that, I get 54 minus 36 is 18. 18 minus 9 is 9, minus 1 equals 1. So that means, looking at that, p of 3 doesn't equal 0. Therefore, x minus 3 is not a factor. Okay, we can say that that's definitely the case. If we'd got 0 there, it would have been a factor. Now we're looking at factorizing, okay, the process of factorizing polynomials. So there's two parts to this question. We factorize first up and then we solve secondly. Okay, so let's have a look at this question in more detail. Okay, let's look at our polynomial here. We've got 2x cubed minus x squared minus 13x minus 6. Okay, that's our polynomial. Alright, so that's p of x. Now, what we're going to have to find is a number that will go in for x into that polynomial that will give us a result of 0. Because once we've done that, according to the factor theorem, we should have found a factor. So we have to find out whether p of 1 equals 0, question mark. Does p of negative 1 equal 0, question mark? Does p of 2 equal 0, question mark? Does p of negative 2 equal 0, question mark? So on, so on. Okay. we've got to find that first factor. Now, I've sort of already know what it's going to be here, but I'll do one failed attempt because you may be able to work it out using a bit of mental arithmetic. You may have to use trial and error. So, for example, I'd start at P of 1. I can sort of look at this through experience now. I can tell it's not going to be P of 1, but we'll try it anyway. So let's look at P of 1. That was going to be 2 times 1 cubed minus 1 squared minus 13 times 1 minus 6. Now, I mean, you can work this out if you like, but you can look at it straight away and say, look, I'm not going to get 0 out of that. I mean, that's going to be 2 there, negative 1, negative 13 take 6. So it's just not going to be 0. Okay? So I can tell straight away from that P of 1 is not equal to 0. Therefore, that would mean that the opposite of 1, that is x minus 1, is not a factor. Okay, so that's established. Okay, so what is one of our factors? Now we could work through sequentially here. I'm actually going to go straight to the solution that does give us 0. And the first one you'd find that would give you 0 would be P of negative 2. So let's look at that. P of negative 2. That's going to be 2 times negative 2 cubed minus negative 2 squared minus 13 times negative 2 take 6. Okay, so that's P of negative 2. Equals negative 16 take 4 plus 26 minus 6. Well, that comes to 0. And that's great, right? Because that means that x plus 2 opposite sign is a factor. Okay. Excellent, we've found one factor. How are we going to find the other factor? Well, to find other factors, we're going to, what we're going to do that is we're going to actually divide our polynomial. So that's 2x cubed minus x squared minus 13, pen's not working, minus 13x, get this pen to work in a sec, not wanting to work for me, here we go, minus 13x minus 6, we're going to divide that by x plus 2, because that's our first factor. Alright, so that's what we're going to do now. Now this brings in a skill that we've done in the previous video, and that is division of polynomials. So let's remind ourselves of what we do there. Okay, that's what we've got to do. What we've done is we've found our first factor, x minus 2, okay, and we've now got to find the other factors as well. So when we divide, remember we can use here synthetic division for x plus 2. So in synthetic division I put the coefficients up the top. It should be x squared there, sorry. Put the coefficients up the top here, negative 13, negative 6. Remember how I did that? And to the side of this grid I put the opposite sign of x plus 2. Okay, our divisor there, x plus 2, is opposite sign is negative 2, and then it's bring down the 2, multiply, 2 times neg 2 is neg 4, and add neg 1 plus neg 4 is neg 5, multiply, neg 2 times neg 5 is 10, add negative 13 plus 10 is negative 3, multiply, neg 2 times neg 3 is 6, add, and we get 0 there. So when we do this synthetic division, if we've got the factor, and we should always get 0 there, because remember x plus 2 when divided in will not show us a remainder, so there's no remainder there, which is a good thing. So that means we've now got x plus 2, which is our first factor, multiplied by 2x squared minus 5x minus 3. One more step in factorising, because what we've got to do now is factorise this last expression here. So here it is. Got to factorise this bracket. So how do we do that? There's a number of ways of doing that. I always rely on a grid method, by which I put down the factors of 2x squared, 2x and x. I put down the factors of negative 3, and I look for a combination of those factors that are going to give me an overall result of -5, the middle term. Okay, so you look at those two there on the left, they're the factors of 2x squared, and they're factors of -3. Now, I've chosen the right combination. You may not have. You might have put -1 there and +3 there, or you might have alternatively put, if I rub those out, you could have put a -3 there, sorry, there, and a 1 there, all sorts of different combinations, alright? But we're looking for a combination that when we do this cross multiplication, which I'm about to show you, okay, why does this combination here win? Because if I times across that way, that's -6x. If I times across that way, that's +1x. What's the overall total? It's -5x, and that's my middle term. So those two there, 2x and 1, so 2x plus 1, and those two there, x minus 3, become the result of factorising 2x squared minus 5x minus 3. Alright, so there we've done it. We've factorised successfully. Last thing to do though, notice the question had two parts. Okay, it had this solve bit here. It had solve 2x cubed minus x squared minus 13x minus 6 equals 0. So, let's look at that. There it is. We've now factorised it. So it's x plus 2, 2x plus 1, x minus x, oops, sorry. Try that again. X minus 3 equals 0. Solutions to that are the opposite signs. X equals -2, -1/2, and 3. And that's the three solutions. Let's go back over that factorising method just one more time. Okay. First thing I had to do was find the first factor. And you can do that by trial and error. You can do that by sight. Now if you've got good mental arithmetic, you can start in your head putting some numbers in. Doesn't matter. But what you've got to do is successfully find a number that when placed into the polynomial gives you a result of 0. And I did that there. The opposite sign to that number is the first factor. So x plus 2 was the first factor. I then divide my polynomial by that first factor, and I've used synthetic division to do that. And once again, pause this video, go back over the method if you're unsure. That gave me a result of this, which meant I had to factorise the second bracket. I've given you one method there. Your teachers in the past might have shown you other methods for factorising that. Of course, I will be showing you how to do this on your calculator as well. Once we've done that, the last part of the question was to solve. We make the three brackets equal 0, and the opposite signs of the brackets give us the results for x there. Okay, I want to finish this video with an exam standard type question. Find the value of a and b if x plus 1 and x minus 2 are factors of ax cubed minus 4x squared plus bx minus 12. Well, if these guys are factors, according to the factor theorem, then p of -1, opposite sign, should equal 0. And also, p of 2 should equal 0, opposite sign. So let's do that. Let's make p of -1 equal 0. So that means a times -1 cubed minus 4 times -1 squared plus b times -1 minus 12 equals 0. Let's tidy this one up. We'll do p of 2 equals 0 in a minute. So this is going to be -1 cubed is -1, so it's going to be -a, -1 squared is 1, -4 times 1 is -4, -b times -1 is -b, minus 12 equals 0. Negatives with the a and b are awkward, so what I try and do here is create a situation where we've got a and b being positive. So you'll notice, if I take a and b over the other side, we've got a negative a and a negative b on the left, we get a plus b, okay, and we've got the numbers remaining on the left, we get -16 equals a plus b. Alright, so that can also be written as a plus b equals -16. We'll continue on the next slide. Alrighty, so just resuming this question, we've got a plus b equals -16, and that comes from the fact that p of -1 equals 0. Alright, so Now we're going to look at P of 2 equaling 0. So P of 2 equaling 0 be A times 2 cubed minus 4 times 2 squared plus B times 2, so 2B minus 12 equals 0. So that's 8A minus 16 plus 2B, take 12 equals 0. Therefore, 8A plus 2B equals, if we take the negative 16 and the negative 12 to the other side, we get positive 28. Okay, so there's our two equations. Okay, equation 1 is A plus B equals negative 16. Equation 2, 8A plus 2B equals 20. Equals 28. That's equation 2. Okay guys, I used a bit of a tactic last time called substitution, and we could probably use it again. So if I look at this equation here, this first one, here, if I change it round, if you change this one around here, you get B equals negative 16 minus A, something like that. So if I substitute that, so I substitute equation 1, which is now that, change it around, into 2, I get 8A plus 2 lots of B. B is negative 16, take A, equals 28. So 8A minus 32 minus 2A equals 28. 6A, 8A minus 2A, equals 28 plus 32. Taking the negative 32 to the right, that equals 60. A equals 10. Is the answer there. So once we've got A, as per usual, we can just substitute. Let's use the room up here. We substitute that into the first equation. So we know that A plus B equals neg 16. 10 plus B equals neg 16. B equals neg 16, take 10. B equals negative 26. So overall answer, A equals 10, B equals neg 26. Alright guys, you could probably have a go now at exercise 1C. Questions 3 through to 11. Good luck with it. Thanks for listening.